Hi everyone, this is our lecture on ornithine transcarbamyalase deficiency. So let's get started. To get a clinical perspective, let's look at a quick flash case. Let's say a 17-year-old male is brought to the emergency department via ambulance after an episode of confusion during a football game. His parents report he had a stomach bug the last few days because he had a low appetite, vomiting, and told them he was tired. Let's keep this in mind as we go through the lecture. Our learning objectives are to recall the site in the urea cycle where the enzyme ornithine transcarbamyalase is utilized, and to recognize the laboratory findings and associated clinical findings of ornithine transcarbamyalase deficiency. First, let's get oriented. Let's take a step back and remember where we even use the enzyme ornithine transcarbamyalase before we talk about what happens when it's deficient. Here, let's review the urea cycle. Remember, the whole point of metabolism in all of these pathways is to give us energy or fuel. Now, to get some of that metabolic fuel, we break down amino acids to generate some useful metabolites, like pyruvate and acetyl-CoA. What happens, though, when we break down an amino acid? I know this is going to be a terrible throwback to biochem, even undergraduate organic chemistry, even high school biology. But what is an amino acid made up of? Remember, our nucleosides and nucleotides have nitrogenous bases, and the nitrogen can form ammonia. Here is where the urea cycle comes into play. We don't want that excess nitrogen from amino acid catabolism hanging around. We want to gather up that excess nitrogen seen here and use the urea cycle to make urea, because we can excrete urea with our kidneys to eliminate it. However, to get that all done, we need to go through the urea cycle, and that's where we need ornithine transcarbamyalase. Now, ornithine transcarbamyalase deficiency is the most common urea cycle disorder. It is X-linked recessive versus other urea cycle enzyme deficiencies, which are autosomal recessive. Like I mentioned earlier, a deficiency in this enzyme will interfere with the body's ability to eliminate ammonia. Now, let's look back at the urea cycle. If there's a deficiency in ornithine transcarbamyalase, then what will build up? We'll start having a buildup of carbamoyl phosphate, which uses ornithine transcarbamyalase to make citrulline. Can you remember when you've heard of carbamoyl phosphate before? You're right if you're thinking of pyrimidine synthesis. Now here we have both the pyrimidine and purine synthesis pathways, with the pyrimidine one on the left. You can see that carbamoyl phosphate is part of the pathway, which is converted to orotic acid. Can you remember which one of the nucleotides and nucleosides are pyrimidines? That's great if you said cytosine, uracil, and thymine, which have carbamoyl phosphate. So, that excess carbamoyl phosphate we get when there's a deficiency in ornithine transcarbamyalase will get converted to orotic acid. Okay, so how is someone with ornithine transcarbamyalase deficiency going to present clinically? The condition is often evident in the first few days of life, but may present later. With blood work, we would see increased orotic acid in the blood and urine. We'd also have a decreased BUN and no megaloblastic anemia, which is important so that we can compare it to orotic aciduria. Now, clinically, a patient would present with symptoms of hyperammonemia. Can you name a few symptoms? You're right if you're mentioning asterixis or a flapping tremor, slurred speech, somnolence, and vomiting. Okay, that was a lot of information. Let's do a quick quiz. What is found in excess in ornithine transcarbamyalase deficiency? That's great if you said orotic acid. Without ornithine transcarbamyalase in the urea cycle, carbamoyl phosphate shifts to the pyrimidine synthesis pathway and is converted to orotic acid. Let's go back to our case. Here's a case of a 17-year-old who seems confused, and his parents are saying he had a stomach bug because he isn't eating well. He's vomiting and he's tired. Yes, absolutely could be a stomach bug, or a number of other things. What if we said he had elevated uric acid in the blood and urine? Then what would you consider? Well, you could consider that these symptoms may actually be due to hyperammonemia, secondary to ornithine transcarbamyalase deficiency. Remember to have a running list of differentials as you go through cases, which is why knowing the unique aspects of certain diseases can help you rule in and out different diseases. So, what's the bottom line? Ornithine transcarbamyalase deficiency is the most common urea cycle disorder and is X-linked recessive. It results in excess carbamoyl phosphate getting converted to uric acid as part of the pyrimidine synthesis pathway. And findings would include increased uric acid in the blood and urine, decreased BUN, and symptoms of hyperammonemia. That's all I have for you here. Please give this video a thumbs up if you liked it, and it'll give you the opportunity to submit a comment if you have any feedback or questions. Thanks for joining me. Study hard.